As we all know, the research of space industry and nuclear technology is more and more significant to individual citizens in the 21st century. Let's imagine this scene now. With the money that you and your roommates have earned in the civilian use of your tactical nuclear weapons, you have successfully transformed your dormitory into a Project Orion spacecraft, which has supported you for a cool summer vacation on Mars. However, because this process requires a large number and intensive nuclear weapon explosions, the University Alliance decided to take sanctions on your school and bombed the transformer substation and the boiler room of the public bathroom. In order to solve the sanctions, while launching an RS-28 Sarmat intercontinental ballistic missile to destroy the University Alliance, you must lead the whole student union to build a new nuclear explosion boiler deep underground under the school. Use a large number of tactical nuclear weapons stored in the school's warehouse to supply enough power for the whole campus and provide enough hot water for the public bathroom. First of all, you need to dig a deep hole which must go straight into the bedrock layer, preferably more than 100 to 150 meters into the bedrock layer. Then, put a tactical nuclear device in and detonate it. Our goal is to blast a large hole with a radius of about 50 to 60 meters. Then, we need to shape it into an ellipsoid in the up and down directions by using a shovel. Finally, we need to add a layer of steel on the inner wall of this large hole. Next, make a large number of small holes on the inner wall of the big hole. Make a hole at the upper and lower ends of the big hole, respectively, and then connect the pipe to every hole. In this way, the explosion chamber will be built. Finally, we need to dig another hole. The inner wall of the hole is also covered with a layer of steel as a storage place for the thermal mass, which is responsible for holding the heat. The thermal mass should be potassium-sodium alloy because it can contain liquid state without heating. You may need to contact your high school chemistry teacher and buy 30,000 to 40,000 tons of potassium-sodium alloy for him. The workflow is as follows. First, pump about 30,000 tons of liquid potassium-sodium alloy into the wall of the explosion chamber through the pipeline and all the small holes. Immediately, lift the nuclear device right into the center of the explosion chamber with a fishing rod and detonate it. The liquid potassium-sodium alloy will be heated to thousands of degrees Celsius immediately and leave the explosion chamber from the upper and lower pipes. Flow into the heat exchanger and boil the water quickly in it. Then, the high temperature and high pressure steam will leaving the heat exchanger and flow through a large supercritical steam turbine to generate electricity. Then, after the steam is cooled down, a large amount of hot water can be used in public bathrooms and heating systems of the campus. Then, after checking the explosion chamber and confirming that there is no problem at anywhere, the cooled potassium-sodium alloy can be pumped into the explosion chamber, and the next round of nuclear explosion and power generation cycle can be carried out again and again. Well, since the nuclear device selected should not exceed 10,000 tons of trinitrotoluene equivalent, your safety consultant, Clatu Tehenu Wagner, will teach you how to simply measure the approximate trinitrotoluene equivalent of nuclear weapons by owning velocimetry the scraps of paper in the next tutorial. Warning: Wagner Safety Education Tutorials reminds you, if the heat exchanger or steam turbine leaks, because the water vapor under high temperature and high pressure is nearly transparent. It will be difficult for you to find the leakage point before being cut off or being cooked by blanching. So please, be careful, okay?